Good evening, guys. Welcome, all of you. Very good evening. So, we are here once again, guys, and we are going to study some important questions on reactive intermediates. What are we going to discuss today? We have some really important questions where we are going to discuss benzene mechanism. Okay? Yes. Very good evening to all of you once again. And let's wait for 1 minute for your friends to join in as well. Today in the morning session, that is in the morning plus session only, we had discussed the important reactions of benzene, right? How the benzene is formed and how it is reacting regioselectively. All right. So that is what we have discussed in the Unacademy plus session. Okay, so we are going to continue our discussion over here with very important examples. Also, guys, if you have not yet joined the Telegram group, please do, because there I'll be sharing all the important links. Okay. Yes. So everyone is here. All right, guys. Chalo. Let's start with our questions. Also, we are going to compare that there are some reactions which you might be confused about whether it is going through a benzene mechanism or a simple SNAR mechanism. So that also we are going to consider over here. Since we have also completed substitution nucleophilic aromatic in the plus classes, so we are going to also solve questions on that as well. Right? Okay, guys. Good evening, everyone, once again. All right. Just let's start with a simple question. Question number one, that is, let's say you have this molecule. How is it going to react in the presence of heat with maleic anhydride? What is going to be the product? Yes, guys, good evening. Good evening, everyone. Simple question to start with. Also, one more important thing, guys, tomorrow 8 p.m. we have a special class. All right. So tomorrow is 29th of October. 29th of October, I have kept a special class on Unacademy that is going to be complete organic practice. Okay, because you are going to have a scholarship mock test on 30th of October. I will inform you about that shortly, right? So that is why for complete revision of organic, we will be having a complete organic practice session. Okay? Chalo. So what's going to happen in this session? Yes. ये देखो ये क्वेश्चन का क्या आंसर होना चाहिए गाइस? Right? So actually this is a very simple question, guys. Since I have already told you we are talking about benzene, so you can directly think of it. The bonds are going to move in this direction in such a way that you are generating benzene out of this. Okay, we had discussed this in the morning in the plus sessions, right? So that the molecule is going to eliminate nitrogen as well as sulfur dioxide and creates this benzene molecule, which on reaction with this molecule can give you a 2 plus 2 cycloaddition. Right, so 2 plus 2 cycloaddition is actually more favored in the photochemical processes, and a benzene reaction, pericyclic reaction guys, 2 plus 2 cycloaddition more favored in the photochemical conditions. So you can absolutely get this kind of a molecule. All right, and 4 plus 2 cycloaddition is also possible. So let's say if I had taken some other molecule, some other dye in, it would also give a 4 plus 2 cycloaddition. And if nothing is taken, let's say I only have heat and nothing else is taken, no other reagent, so only in the presence of heat, the benzene can itself also dimerize in such a way to give you this molecule, right? This also we had discussed in the morning. So this was first question based on benzene reaction mechanism, benzene intermediate. All right. Yes. Now, guys, one more important question. Look at this. It was asked in June 2019, a question on benzene mechanism itself. See, there is 3-chloropyridine, and I wanted to discuss this. Is a very, very important reaction for selectivity and the type of mechanism. What is going to be the product for this reaction? Is it the SNAR mechanism or is it benzene mechanism? What is going to be the product? Yes, is it SNAR mechanism or is it a benzene mechanism? How are we going to identify? That is the question. No, 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 it's the benzene mechanism, Shuman. It's not SNAR mechanism. Why? How do we know? We know by the position of the chloro group. Okay. So if let's say I say that I want to do substitution through amide and the chlorine is present on the second position like this, then it is possible through SNAR, that is NH2 minus going to attack over here Electron density goes on to nitrogen. You have Cl and NH2, and which is a better leaving group. Depending on that, you will have the substitution. So better leaving group is absolutely chloride. It is going to leave. You are going to have substitution like this. So this is SNAR mechanism, that is your addition elimination mechanism. The same is going to happen if we are taking 4-chloropyridine. Yes, if we take 4-chloropyridine, then also the same reaction can happen. Why? Because the electron density can travel all the way down to nitrogen like this. The electron density can travel like this. Otherwise, yes guys, it's also going to give you 4-aminopyridine like this. It's going to give you this product, but the same reaction cannot happen on the third position. Yes, right. So if we want to do the same reaction, NH2 minus attacking over here, the electron density can never travel on nitrogen. It is only going to stay on a carbon. So that is why, see, it is not favored. This kind of reaction is not going to happen. Okay, so what do we do otherwise? Other than this, what can we do? We can take the pyridine molecule. Let's say I'm writing the 3-chloro over here. Yes, this side I'm writing the chloro. And you know that amide is a very strong base. This is one more identification of the benzene reaction mechanism, that whenever you have amide base, which is a very strong base as compared to other nucleophiles like methoxy or other nucleophiles like some other alkoxy group, or let's say some other butyl lithium is also a very strong base. So from amide to alkyl bases, they are all very strong, right? So this is going to take away a proton which is more acidic. You have two choices once again. See, you have this hydrogen, you have this hydrogen. Why are we? Yes, yes शुभंकर, यूजुअली 6 PM सेशन है, लेकिन अभी फिलहाल आज एक्सेस नहीं हो पाया था 6 PM सेशन और 6:30 PM सेशन. दैट इज व्हाई वी आर हियर एट 8 PM. ऑल राइट. Okay, so yes, all right. So what do we have now? We have this benzene. It is not exactly benzene, but it is arine. You will call it arine because it is coming through pyridine, right? Yes. Now what happens is this arine is going to form, and why not this one? Why this is not going to form? Because the proton on the fourth position is more acidic. Also, if this proton is removed, there will be electron repulsion, electron repulsion from the pyridine nitrogen as well as the electron density in the benzene. So that's not favored. That is why this is not going to form. We can proceed with this reaction now, guys, and it is going to give you both the products, the ipso and the sine product. What is the ipso product? That is the amide when it attacks on the same carbon where the Cl has left out. That is known as the ipso product. Okay, and there is hydrogen once again. This is ipso, attacking on the same carbon where the leaving group has left, and NH2 over here, that is on the adjacent carbon. This is known as the sine product. Okay, yes, yes, parahydrogen का ही abstraction हो रहा है. Yes, so this is the correct answer. You are getting two of these products. दोनों सही है. A mixture of both you are going to get. So there are many other reactions which could be confused into SNAR and benzene. हम उन्हीं के example देख रहे हैं आज. Benzene is also an intermediate. ये देखो, we have one more very important reaction. It's a question based on rate of reaction. Previous year question only. based on the rate of reaction. Yes, look at this. Correct rate of reaction of the following. Okay, so first one is iodobenzene reacting with NaNH2 to give you this molecule NH2 like this. Then this is K2 where it is the chlorobenzene once again reacting with NaNH2 sodium amide, giving you amide over here. Right, third reaction is you are having para nitro iodobenzene. This is K3 and you are having sodium ethoxide. You don't have the amide, you have ethoxide over here. And this is OME, yeah, OET. Since there was ethoxy, we are writing ethoxy. And the fourth example is where we are having fluoro nitrobenzene like this. K4 and once again ethoxy. Like this, right? So we have a condition, guys, that what is going to be the correct set of rate constants, right? K1 is greater than K2 and K3 is greater than K4. C is K2 greater than K1 and K3 greater than K4 and D is K2 greater than K1 and K4 greater than K3. Okay? So which one do you think is correct? Yes, everyone. So which one is the correct answer? Yes, very good all of you, Rituja, Suman, and yes, Shalini, I guess. Okay, chalo. Right, so what's the correct answer, guys? In the first two reactions, in these two, first one, this is benzene mechanism. Why? Because we don't have an electron withdrawing group and we have a strong base. These are the two important identifications. So a proton is removed from here, it's a benzene mechanism. And this is also a benzene mechanism over here, both of these two. So benzene mechanism, guys, in the benzene mechanism, yes, you are going to see that a good leaving group is going to drive the reaction faster. Why? Because the mechanism is elimination addition. Yes, right. Benzene mechanism को हम बोलते हैं elimination addition. Right. So first and the rate determining step is elimination. Which one is a good leaving group? This one. Iodine better than Cl minus. So K1 is going to be greater than K2 with respect to the good leaving group thing. Now third reaction and fourth reaction. They are going through SMAR mechanism. This is also SNAR, yes or no? Yes, it is going through SNAR mechanism. So guys, SNAR mechanism के अंदर you will always see that the more electron negative atom is going to invite the nucleophile more strongly, like this. ठीक है? And that is why the fluoro is going to drive the reaction forward, because the rate determining step is addition, right? That is why 4 is going to be, K4 is going to be faster than 3. So our answer is option number A only. Yes, very direct question, guys. Comparing these two things. Okay, chalo. Let's do one more question on benzene mechanism. And before moving on to that, guys, let me remind you all that there are only 2 days to go for the All India CSIR NET scholarship test. And guys, this scholarship test is going to be on October 30th. For those students who want to join Unacademy Plus, for them it's a golden chance to win 100% scholarship, right? And you can directly enroll for free. This is a free test for everyone. For those who want to just know about their ranking all over India, how students are giving this test, how they are performing, this is also a very good opportunity. So I would request all of you once again to enroll in this mock test for free, right? And these are the ranks. Rank 1 holder is going to get 100% scholarship, and so on, guys. You can see. So there are only 2 days remaining for this. That's why we are doing so much practice. And yeah, do not forget to enroll in this course. Also, for those who have already joined Plus, don't forget to enroll in this course. This is a new course, detailed course on inorganic chemistry for CSIR NET, right? And for those who have not joined, please use the code Jagriti S Live for joining up. Okay, all right, guys. So let's move onwards to question number 4. Yes. Now look at this question. The question has two parts. One is the intermediate, and second is the product. All right. Orthobromoanisole. In the presence of first step, in the presence of LDA, which is given only one equivalent. Second step, you are having malonate, CO2Me, CO2Me, malonate anion. Alright, the anion is given directly. What is option number A? This is your intermediate, and without any addition of further reagent, that gives you B. So what's that, guys? What is A and what is B? Let me write the complete question. Okay, so this is A, all right, and this is B. Okay, option number B goes like this. So you have to select the correct option, guys. Yeah, there's a minus charge over here, right? All right, D is none of these. So which one do you think is the correct answer? Yes, Shubhankar, see, if you have already got your integrated PhD after, see, there are students who can give the examination, CSIR NET examination through BSc, right? And when the BSc is over, they can enroll for MSc PhD integrated course, and they will be automatically given the fellowship, right? So there is this option of JRF. You can directly give JRF after BSc for integrated PhD, in which you will be provided the scholarship. That is the fellowship, right? And if you're asking for those students who have already taken admission into integrated PhD, you can ask your guide. You can actually ask your guide if there is any possibility I can get fellowship through this, or through any other method. If I can get fellowship, they'll guide you on this. What kind of fellowship is available? All right, guys. So yes, what do you think is the correct answer of this question, everyone? ये देखो क्या हो रहा है, guys? You are having a ब्रोमोएनिसोल। हाँ, बीएससी के बाद डायरेक्ट बीएससी के थ्रू भी आप जेआरएफ दे सकते हो, बट यू विल ओनली बी एलिजिबल फॉर जेआरएफ। आप एलएस नहीं कर सकते, एलएस का एग्जाम देने के लिए एलिजिबल नहीं हो, बिकॉज एलएस लेक्चरशिप रिक्वायर्स मास्टर्स, बट आफ्टर बीएससी you can give JRF examination which is going to help you get fellowship for integrated MSc and PhD. Absolutely you can. ठीक है, right. चलो guys, so we are talking about this question now. Let's see कि इसका आंसर क्या है. First of all, see, there is LDA and only one equivalent, which means it is going to pick out a proton, acidic proton, and it's going to give you a benzyne. But LDA is not the nucleophile, जैसे कि हमारे पास NH2 minus होता है, which is the nucleophile also. Base and nucleophile works both, but LDA सिर्फ one equivalent है. So it is going to, LDA is a diamide like this. So LDA is going to remove this proton and give you a benzyne. So first thing that you are going to form over here is benzyne like this. This is the only benzyne that you can create over here. All right. Second step is you have malonate carbanion. So this carbanion is absolutely going to attack on such a position which will create a negative charge close to methoxy. And in the morning only I have told you today, benzyne mechanism may you are not going to consider resonance or anything. Why? Because the resonance is inside the ring, isn't it? Resonance तो ring के अंदर हो रहा है ना. अच्छा, sorry, this is going to be like this. Resonance only happens inside the ring, so you are always going to consider the minus I effect of such groups. So the negative charge is going to be really stable on the ortho close to the methoxy. Always more stable close to the methoxy. This is wrong option. ठीक है? Option number C is wrong. Option number A or option number B it could have been. ठीक है? Then we move onwards. We see कि A तो intermediate मिल गया हमें, but after A we are not providing any reagent. ठीक है? तो अगर कोई reagent provide नहीं कर रहे हैं तो क्या होगा? ये इसी पे attack करेगा like this. And when the oxygen bond opens and falls back, ये वाला bond यहाँ से उठ जाएगा, यहाँ से break हो जाएगा, and you get a negative electron density on this carbon right over here. That is going to take away a proton from the aqueous workup, and your answer is option number A finally. This is going to be the correct set of option. Okay, B is wrong because एक carbon missing है यहाँ पे. There is this one carbon missing. That is not correct. Okay, so we are going to move onwards and we see another very nice question. Alright, one of the previous year questions about the same topic. See, you are supposed to give the major product A and B, right? There is a R group, there is an alkyl group over here, and on the fourth position you have bromo. So when you are having the R group as methyl, that gives you product B in the presence of the same reagent, sodium amide and liquid ammonia. Okay, and when you are having the R group as OH and the same reagent, sodium amide and liquid ammonia, that is going to give you A. अब आपका question ये है what is A and B, that you have to figure out. So already I have made you do this in the plus class today, so I hope that you will be able to answer. All right, yeah, look at this. This is A and B is going to be this is to this in 1:1 ratio. And what is option number B? A is this molecule para substituted phenol, right? And B is meta substituted product. Third option. Now A is going to give you a mixture of this plus this in 50-50 mixture or 1:1 ratio. And B is going to be para major and D is none of these. Yes. So I made you do this question today in the morning itself, guys. A and B. Yes, guys. Previous year question, it is CSIR NET June 2015. Already been asked. Tricky question directly from Claydon. Yes, guys. So in the morning only, I have told you about this. That is, whenever, alright, let's try to explain this in the next page. Whenever you have the R group as a methyl, let's say it's a methyl over here and there's a bromo over here, right? So in the presence of a base, strong base like amide, you have only one possibility, either abstract this hydrogen or this, you are going to get only one benzene. Like this, isn't it? You get only one benzene. Okay? The NH2 minus can now attack on this position or on this position. That is going to lead to two different products. Now, why are these products different? These look different because there is a methyl. If there was no methyl and if we just had simple benzene, तो हमें पता भी नहीं चलता कि अलग अलग product है, isn't it? Yes guys, if there was no methyl over here, तो हमें ऐसा लगता same product है, but since we are having methyl, it is making a difference. So methyl or any other alkyl group which is not very bulky is going to give you no specific preference for any major product. That is why both the products will form in 50-50%. ऐसा क्यों हुआ guys 50-50% both the products? Because methyl हो या कोई भी alkyl group हो जो बहुत ज़्यादा bulky नहीं है, वो कोई खास preference नहीं दिखाता है on the benzene. It is just like having a benzene on simple benzene. ठीक है, simple benzene पे हाइड्रोजन होता है, यहाँ मिथाइल है, इथाइल, प्रोपाइल, until and unless अगर आपके पास बहुत ज्यादा bulky group है like tertiary butyl and your benzene is let's say like this. अगर आपके पास tertiary butyl है और आपका benzene ऐसे form हुआ है, then maybe this meta attack is going to be more preferred because of steric interaction, but ऐसा तो कुछ है नहीं हमारे पास फिलहाल. So that is why 1:1 product formation over here, right? So this is very important everyone. Yes. What about the next part of the question? The next part of the question says, yes, option number A. So B is going to be 1:1 product. This one. This is correct. All right. Next part of the question says if you are having OH, then what is going to happen, guys? OH के लिए कौन सा product major होने वाला है? Let's see. Whenever you have, see benzene is exactly the same. यही वाला benzene बनने वाला है आपके पास, but phenol से phenolate हो जाएगा क्योंकि basic medium है इसीलिए, right? So if you usually had methoxy, so methoxy would try to make the attack in such a way कि नेगेटिव चार्ज ऑक्सीजन के पास रहना चाहिए, isn't it? मिथॉक्सी होता तो अटैक पैरा पोजीशन पे होता सो दैट नेगेटिव चार्ज रिमेन्स क्लोजर टू ऑक्सीजन, लेकिन यहाँ पे तो O माइनस है ऑलरेडी, इसके पास ऑलरेडी नेगेटिव चार्ज है, इसीलिए अटैक ऐसा होगा, attack will be on meta position such that the negative charge goes far away from this oxygen, and that is why you are going to get this kind of a product. Final product after aqueous workup is going to be like this. Meta product is the major product. All right, so your answer is option number A, this one right over here. Okay, right. So guys, we have done few of the questions on the benzene mechanism. Right, there are plenty of things, plenty of questions in the previous years to be practiced from. हमने अभी सिर्फ 5 क्वेश्चन किए हैं, 5 important questions करे हैं, and we are going to continue the reactive intermediate series tomorrow and day after tomorrow, right? So throughout this month of October, yes, 29th of October 8 p.m. you are going to see me on a special class on Unacademy. इस स्पेशल क्लास में गाइज हम लोग प्रैक्टिस करने वाले हैं ऑल द इम्पॉर्टेंट क्वेश्चंस ऑफ ऑर्गेनिक केमिस्ट्री, ऑल द टॉपिक्स दैट वी हैव ऑलरेडी डन. फॉर एग्जांपल हमने स्टीरियो कर लिया है, स्टीरियो केमिस्ट्री, रिएक्शन मैकेनिज्म कंप्लीट एंड रिएक्टिव इंटरमीडिएट्स. ऑल राइट, दैट वी आर ऑल्सो प्रैक्टिसिंग ऑन यूट्यूब एज वेल. यहाँ पे हम प्रैक्टिस भी कर रहे हैं इसकी. नेम रिएक्शंस and organic reagents. So all of these topics I am going to make you practice in the special class tomorrow 8 p.m. So be there guys. And अभी जब तक ये अक्टूबर मंथ ओवर नहीं हो जाता है, we are going to have sessions at 6:30. ठीक है, 6:30 p.m. we are going to have YouTube sessions every day tomorrow also. All right, and I'm going to see you all soon guys. Yes, and yes, that's it guys. I'll also give you the schedule for the next month as well. हम बहुत सारी important चीजें करनी है अगले महीने से, right? We have to start the preparation for GATE examination also. Next month से हमारा GATE की तरफ focus increase होने वाला है because we have done few topics, right? So we are going to take that knowledge into use for practicing questions. Okay, so I'll inform you about the sessions as well. अभी के लिए this is it, guys. If you want to join up Unacademy Plus, don't forget to use the code Jagriti S Live. And now I'm going to see you all tomorrow in the morning 9 a.m. on Unacademy Plus. Bye everyone. Take care all of you. Have a very good night.